What's up, Logan? This is just a real quick tutorial on how to graph a quadratic function that has transformations, reflections, uh, just the whole nine. So the first thing you're going to do is you're going to figure out what your shift on the graph is going to be. So this right here, we have I would say it's a shift by 3. So we're going to translate 3 right? And then this one over here tells us that we're going to go 6 up. And this tells us something about our vertex of our parabola. So I'm going to go 3 spaces to the right, 1, 2, 3, 1, 2, 3, and then 6 spaces up, 1, 2, 3, 4, 5, 6. So we know that our vertex is going to be located right there. So we have a vertex located at 3, comma 6. So just write that out, 3, comma 6. Now from here, what we want to do is we want to graph it. Now the best way to do it would be using the basic form of the parabola, which means, x squared. So when you plug in 1, that means when you go to the right one. So if you go, 0, you get 0. 0 times 0 is 0. If you go 1, you get 1, because 1 times 1. If you go 2, you get 4, because 2 times 2. If you go 3, you get 9, because 3 times 3. And then if you go to the left one, you get 1, because negative 1 times negative 1. Negative 2 would give you 4, and then negative 3 would also give you 9. Hopefully that makes some sense. If it doesn't, you're going to want to come and talk to me about that. Okay, so from our vertex right there, from that point, we're going to go 1 space to the right. Now, when you go 1 space to the right, normally you would go up 1. Okay, normally it would go up 1, but because it is, let me show you why you would go up 1. Right here, right? You go over 1, up 1. But because it has a vertical stretch by a factor of 2, as well as a reflection into the x-axis, we're going to go over 1 and we're going to go down instead. Normally, we would go down by a factor of 1, but because we have a stretch, right, for those of you that don't know, we have a stretch, a vertical stretch, by the way, stretch in parentheses, vertical, by a factor of 2, by 2, we need to multiply all of our movements by 2. So that means when we go over 1, we're going to have to go down not 1, but 1 times 2, which would put a point right there. So that's what we're going to remember to do on this one here, is we're going to remember to go down, down 1 times 2. So let me erase this. Let me look this look a little bit better. Equals, and then so our vertex, for those of us who don't know, our vertex is at 2, comma 6. And then we're going to go over 1 and then down 1 normally, but because there's a multiplier, we're going to go down 2. Okay, so we have over here. To the left, same thing. To the left, over left 1. Normally we would go up to 1, but we have a stretch by a factor of 2, so we're going to go down 2, which gives us a point right there. Now, if we go 2 spaces over, right? If we go 2 spaces over, we normally would go up to 4, because 2 times 2 is 4. But we're going to have to use a stretch by a factor of 2. So instead of going by 4, we're going to double that, which would take us down to 8. So instead of going down 4 spaces, we're going to be going down 2 times 4 spaces, which would give us something like 8. So over here, go down 1, 2, 3, 4, 5, 6, 7, and 8, which would give us that point there. The same thing's going to happen on the left side of the graph. So we have that. Now, once you get to this stage, you just want to curve it out. All right, so we have 5 accurate points, and we curve our parabola through it here and through here as well. So we have a lot of things going on. Now, just a brief review, I would say that the domain is negative infinity to infinity. I would say that the range goes from negative infinity down here all the way up to a value of 6. So from negative infinity up to 6 and including 6. And then I'd also go on to say what the vertex is. And in this problem, the vertex is located at the point 2, comma 6.